Hello everyone, welcome back to Think Tech, a podcast where we explore the fascinating world of technology and how it's shaping our lives. I'm your host Shivam, and in today's episode we are going to dive into the exciting topic of distributed computing. With the rise of cloud computing and increasing demand for processing power, distributed computing has become more important than ever. From parallel processing to grid computing, there are a variety of approaches to distributed computing and distributing tasks across a network of computers. In this episode, we'll discuss the benefits and challenges of distributed computing, explore some of the most popular distributed computing frameworks and technologies, and examine some of the real-world applications of this powerful computing paradigm. So sit back, relax, and get ready to expand your knowledge of the world of technology with Think Tech. So let us start by understanding what distributed computing is. Distributed computing is a computing model that involves multiple computers connected over a network to work together as a single system. This allows for the processing of large amount of data as well as complex computations that cannot be handled by a single computer. In a distributed computing system, each computer in the network generally is referred to as a node, and each node has its own processing power, memory, and storage. So these three things are there with every node which is participating in a distributed computing setup. Nodes communicate with each other to share data and coordinate tasks, and the overall system appears as a single entity to the user. So whenever you interact with any system, it is very difficult to tell whether that is a single entity or whether a multi-node cluster of hundreds of nodes. So one large-scale example of distributed computing is a web search engine like Google. When a user enters a search query, the request is sent to a distributed system that consists of thousands of servers located around the world. Each server processes a small part of the query and returns the results to a central server. The central server then combines the results and presents them to the user. This allows for fast and efficient processing of large amount of data and also in less amount of time. Distributed computing refers to a system in which multiple computers work together to solve a problem or perform a task. So this is the crux of distributed computing, where there are multiple nodes that work with each other, coordinate with each other to solve one particular problem or perform one single task. Every node in this cluster has its own set of instructions to follow, and they communicate with each other to share data and work towards a common goal. So before understanding why we need distributed computing, let us understand how distributed computing has evolved and basically how it came into existence. So I think the history of distributed systems date back to around 1960s and 1970s, where computer networks were being built or sort of being conceptualized for the very first time. At that time, computer networks were primarily used to share resources such as printers and storage devices. And these networks were used to just share these devices across different computers. However, with the growth of internet and the development of more powerful computing devices, distributed systems evolved to become a complex and sophisticated network of computers that could work together to solve complex problems. So towards the late 1970s, the development of LANs or local area networks also happened, and this development enabled the creation of distributed systems within a single organization. So now computers within a single organization can communicate with each other and can work on a single goal or same tasks. And this basically opened more avenues for people to share even software resources like files and applications over a network, and resources that need not be co-located can be at different locations or can be a little far away as well. And at the same time, the emergence of distributed databases allowed data to be stored across multiple computers. This also allowed organizations to store and manage large amount of data much more efficiently than what was possible at that time. In 1980s, we saw the rise of client and server computing paradigm. So which is basically that you have one server which hosts a particular resource, and then there can be multiple clients which can interact with that server to get access to that particular resource. This architecture allowed for the separation of application logic and data storage, enabling the creation of more scalable and efficient systems. So now you had clear-cut segregation between application logic and as well as data storage and the customers or consumers who are using this application. And to top it all, the development of TCP/IP protocol during this period allowed or enabled the creation of what we today know as internet, which facilitated the growth of distributed systems beyond individual organizations. So as soon as TCP/IP protocol came into existence, now systems across the world could connect with each other and share resources. And then in recent years, the development of microservices, which primarily took off in the last 5 to 10 years, the development of microservices architecture enabled the creation of highly modular and scalable distributed systems. So microservice architecture involves breaking down applications into smaller independent components that can be developed as well as deployed independently. So that is more or less the definition of a microservice, which is a component that can be deployed independently. This approach enables teams to work more efficiently and allows for greater scalability and flexibility because it reduces dependency across teams. So this is a very famous architecture model that is being used where each team owns one or more microservices, but they do not depend on other teams to plan out their deployments and development cycles. They can independently deploy their own microservice, other teams can deploy their own microservices, and the entire system works beautifully in tandem as one single application. So overall, the evolution of distributed systems have been driven by the need to build more scalable, efficient, flexible computing systems that can handle increasingly complex and demanding applications or tasks. And as technology continues to evolve, I'm sure it is very likely that distributed systems will continue to play a increasingly important role in modern computing paradigms. So now let us talk about why do we need distributed computing? What are the benefits that we get out of distributed computing? So as we discussed, distributed computing is nothing but a computing paradigm or a computing model where you have multiple machines that work together to solve a single task. There are several reasons why distributed computing is needed, or several areas where distributed computing has benefited us a lot. The first and the most important benefit that I see with distributed computing is scalability. I think this is one of the primary reasons for using distributed computing, which is to achieve scalability. Distributed systems can be easily scaled up as well as down by adding or removing machines from the network depending on the workload. This makes it possible to handle very large volume of data or very complex computations that was not possible with a single machine. So with scalability, there is a concept of horizontal and vertical scalability. Horizontal scalability means that you can add more machines to your distributed cluster and the overall computation capability of the cluster increases. So this is something that has been made possible by distributed computing itself, because earlier we did not have this capability and we depended on vertical scalability, where you build more powerful machines every time you wanted to perform more complex computations. So mainframes is an example of this, where every time a demand for a more complex computation problem rose, a more advanced or more efficient machine was built. But the problem with that paradigm or that scalability approach is that it is more or less limited to a certain extent. You cannot have ultra powerful systems because then the cost also of those systems become very high, and you do not have the ability to scale down when you do not need that much computation power. So distributed computing not only allows us to scale up, but modern cloud providers also give you an option to scale down. And that is a very important feature to have so that you can manage the cost of running your businesses as well. So this is something that distributed computing has made very easy. The next benefit of distributed computing is high availability and fault tolerance. So distributed systems are designed to be highly available and fault tolerant. If one machine fails, the other machines can take over the workload that the failed machine was working on, which ensures that the system continues to function without any interruption. So in distributed computing, there is a very famous quote which says that if you have multiple machines, any single machine can fail anytime, but all machines will not fail at the same time. And that is the foundational principle on which the entire distributed system paradigm is actually based on. That if you have a single machine, that machine can go down and no one can predict when it will go down. But if you have hundreds or thousands of machines, all 1,000 machines will not go down at the exact same time. And this is what is kept in mind while building or designing any algorithm or any approach for distributed computing. This is especially important for mission critical applications that require high levels of uptime. For example, our card transactions. So if the card transaction network goes down, then it will stop payments all across the world. So this is a very mission critical application that should not go down, and that is why most of the card networks today use distributed systems to ensure that no single node failure can impact the entire network of payments. They have enough tolerance for failures built in the network itself. So this is very important. Distributed computing has made possible development of applications that are always up and never go down for even a single minute. The next benefit that we get from distributed computing is performance. So distributed computing can improve performance by distributing the workload across multiple machines, and by doing this, the processing time for a task can be reduced, resulting in faster response time and overall improved performance. So for tasks which are parallelizable, distributed computing can improve the performance of those tasks by a great extent. Although this is not true for all kind of workloads, and this is something we'll discuss later. But for tasks which are parallelizable, this distributed computing is a very good paradigm to use to get better performance. The next advantage or benefit that we get from distributed computing is geographical distribution of resources. Distributed computing enables collaboration and data sharing across multiple different geographical locations, and this is something that is helpful for companies or organizations that operate in multiple different countries, that have employees or partners in different parts of the world who need to work on a common project. So ability to share resources all across the world is also something that has been made possible with the help of distributed computing itself. So that is again a very huge benefit that we get. The next benefit that we see with distributed computing is cost savings. Cost savings, as we already discussed, distributed computing allows horizontal scalability, which is a very cost efficient method to scale up or scale down your infrastructure. And another important point is that distributed computing clusters can be built with commodity hardwares. So we do not require very efficient or very specialized hardware to build distributed clusters. We can make distributed computing clusters with commodity hardware. Therefore, the cost of building a distributed cluster is not very high, and it's very affordable for organizations. And that is why we see that a lot of organizations are making a switch to open source distributed computing technologies so that they can keep their costs in check, as well as they have the ability to scale on demand. And finally, another benefit another use case that we have been able to solve because of distributed computing is processing of big data. I think we are creating enormous amount of data every minute, every second. There are a lot of videos, lot of articles, lot of data content that is getting created, and we need efficient ways to process that data to generate insights so that we can serve our customers and our clients better by using that data. So earlier what used to happen was there was no way to analyze so much data or get meaningful insights for this much amount of data, and the data used to just lie there and get archived after some amount of time. But now with distributed computing and virtually no upper bound on our computation capacities, we are able to consume petabytes or zettabytes of data and get out meaningful insights from that data, which in turn can help us to build our applications more robust and more helpful and improve the experience of our clients as well. So overall, distributed computing is used in a wide range of areas. and it has enabled processing of large data sets, solving complex problems, enabling real-time decision making, and multiple other benefits. And as the amount of data generated by business, individuals, content creators continue to grow, distributed system is likely to become increasingly important in enabling data processing and generating insights from that data. Now, in the last part of the podcast, I like to discuss why distributed computing is not a silver bullet. Distributed computing paradigm is not meant for all kind of applications. There are still use cases which do not fit distributed computing, and this is because the way that distributed computing or distributed algorithms are designed, they do not support a certain kind of use cases. So let us go through those. So the very first example or very first point is, if you have small data. For small data sets that can be handled easily by a single computer, non-distributed computing is often much more efficient than distributed computing, because in such cases the overhead of distributing data and then processing it across multiple nodes can actually outweigh the benefits of distributed computing. So the time that you will spend to distribute that data to multiple nodes, then collect back that data and aggregate on top of it will be much more as compared to if that data was processed by just a single computer. So for small data sets, we should avoid using distributed computing. Second point where we should avoid distributed computing is if we are trying to build low latency applications. So if your applications require very low latency, if they are ultra low latency applications like a trading platform, non-distributed computing is often a better choice. And this is because distributed computing has a major bottleneck of network communication. Distributed computing algorithms by their very nature are very chatty. They send out a lot of messages across the network to coordinate their tasks. And this introduces a network I/O latency, which is unavoidable and will only increase as the amount of information or the data that it has to process increases. So for applications that require real-time decision making, such as autonomous driving or robotics, non-distributed computing is often necessary to achieve low latency. The next point where we should avoid using distributed computing is if we are looking for simplicity. Non-distributed computing algorithms are often very simple and very easy to implement than distributed computing algorithms. And for small applications or applications with simple requirements, non-distributed computing can often be more efficient and much more cost effective than building a distributed system. Because, for example, if we are just trying to build a small POC or we are just trying to build a MVP product, then instead of spending time in setting up a distributed cluster and then setting it up, getting it up and running, and then actually writing code that can distribute your workload across that cluster, it will be much more easier if you can create a application that works on a single machine, and then you can showcase to your investors or your customers, and then maybe once you decide to do a full launch, you can think about using distributed clusters. So if you want simplicity, then avoid using distributed computing. The next point where we should avoid using distributed computing or where distributed computing lacks is data security. For applications where data security is a primary concern, non-distributed computing can be better suited. This is because distributed computing involves sending data over a network, which can increase the risk of data breaches as well as other security issues, because distributed computing has a lot of nodes that participate in processing of that data. Now, as you increase the number of nodes, your surface area for attack also increases, because if any one node in those group of nodes gets compromised, then your entire cluster has a potential of being compromised. So from non-distributed computing where there was just single machine, you have expanded the surface area to potentially hundreds and thousands of nodes. Therefore, if security is paramount for your application or your organization, then you can still avoid using distributed computing, because the risk of data breach is very real in distributed computing, and we have seen a lot of data breaches happening in applications or for organizations because they were using distributed clusters and not all their nodes have the same amount of security restrictions or security built in. So in those cases, non-distributed computing can be much more secure, because all your data is just on a single machine and you can safeguard that machine as much as you want. So this concludes our discussion of what is not good or when we should avoid using distributed computing. And as I said, it's not a silver bullet. It requires a very careful evaluation of the use case that we are trying to build, and then we have to decide whether we want to use it or not. So with this, I think it's a good point to conclude our discussion. This was a brief overview of distributed computing. We understood what distributed computing is, what was the history of distributed computing, what benefits do we get by using distributed computing, and what are the areas or scenarios where we should avoid using distributed computing. I really hope that you liked this discussion and found it interesting and insightful. Thank you so much for listening to this discussion. Be sure to listen to all our future podcasts by ThinkTech as well. As of now, this is Shivam signing off.